Hello everyone. Today we're gonna learn how to use the Osquery operating system instrumentation framework to explore operating system data by using SQL queries. This is a try hack me room, and we're gonna have the objection of getting a basic introduction to Osquery, what it is, what it does, who can use it. We'll talk about the installation, on which OSs can be installed. We'll check the basic interactions for the Osquery Shell. We'll check the schema documentations, create some basic queries. We'll get introduced to Kolide Fleet, which is a GUI interface for the Osquery Fleet, and it's a Fleet Manager. Also, you can use it to query data from multiple devices. And we will get used to running commands on Linux OS and on Windows. So I'll do a basic investigation on some malicious files that are pre-installed on the device on this try hack me room. So let's get a basic introduction about Osquery. What is Osquery? Osquery is an open source tool that has been created by the Facebook, and it can be used by security analysts, incident responders, and threat hunters to query an endpoint or multiple endpoints using a SQL syntax. So the Osquery can be installed on Windows, Linux, Mac OS, and FreeBSD. We can check the description for the Osquery also on the GitHub, where the Osquery, it says it exposes an operating system and high-performance relational database. It allows you to write SQL-based queries to explore operating system data. So with Osquery, SQL tables represent abstract concepts such as running processes, loaded kernel modules, open network connection, browser plugins, hardware events, or file hashing. So basically we can do SQL queries on the operating system and granularly select for what we're looking for on this particular system. So using Osquery, we'll be able to query for indicators of compromise, for threats, and enumerate the machine to find out what happened, or more information about the incident that we want to investigate. So for this particular room, we're gonna use the attack box, which is a web emulator, and we'll start the machine where we're gonna remotely access it and conduct some basic queries and do our investigation. I'll just pause here and wait until my machine boots up, and then I'll get back. Okay, so my machine booted up and the attack box opened up, and we can proceed to the next step. Installation. In this case, I'm using the emulator from the try hack me, so I don't have to pre-install anything and I don't need to configure anything. But if you want to install it on your own device, you can go to osquery.io and see the installation. Like here I have the guide, like they have it, the guides for all the OSs available. And if you need to download it, you'll just go to the osquery.io, and here you can check more details about the Osquery, and here is the download Osquery, and you can select which version you want to download. The latest one is 5.2.2, and here is the all available system operation system files to download to install on your device. So if you want to install it on the Windows, you'll click download. Here is the hash, so you can check the hash, make sure there is its integrity has not been compromised. So if the hashes match after you download to your device, then you're good to go. Alright, let's come back to our command. So in this case, I'm going to use the tool to RDP to this Windows machine. Like I have the machine IP address, username and password. And on this emulator I have installed a Remina tool, which is a tool that will help me to RDP, like to access remotely another desktop. So I'm gonna use this tool. I'm gonna give it the IP address which I have from the try-hack-me. So it's 10.10.227, and I'm gonna give the username. And the password. Also, I'm gonna click on user client resolution so I can have it like on the big screen, not just like partially seeing the screen from the remote desktop. And I'll pop up some locking keyring, close down. And here is the certificate. You need to accept it, and then we can get access to the Alright, so we successfully remotely accessed this Windows machine. Now we're gonna check the basic interaction with the Osquery Shell. So in order to interact with Osquery, we can use a CMD or PowerShell, and we'll run the Osquery I command. So I mean, usually I try to use PowerShell, but this system is really lagging, so I'll just use the command line. And like I said, the Osquery here is pre-installed, so that's why I can run it. Otherwise you'll not be able to run it. You'll need to pre-install and pre-configure the Osquery in order to run it. Okay. So in order to know that we successfully enter into the interactive shell with the Osquery, we can run the command .help, and this all commands that has a dot in front of it, they are called the meta command, and you don't need the colon at the end if you run a meta commands. So these are like help commands. So what we have here, the most one that we more likely to use will be like .tables, which will list names of tables, and .mood, which will choose the mode in which one we want to see our outputs. So for example, to list all available tables that can be queried, we'll use .tables, and we'll get all available lists for the Windows machine. Another way to see all these tables, we can go to Osquery tables. See if no, it's not this one. Schema. So for example, I would need to know what's my current version of the Osquery on that particular device, and I'll choose which version I'm running. And then I'm gonna choose which operating system it has. And based on those two conditions, it will output what tables available for this particular OS query version. But also you can use .tables here and it will give you the same output, but specifically for this version on this particular device. So like that's what we use tables. Like we'll query data from those tables. So for example, we want to see what tables available for the processes. So we'll use .tables processes, and we got one table available for this particular table. So for example, just knowing what tables we have available, it's not enough to know exactly what information is contained in a given table. So to know what information it can be contained in a given table, we use a .schema, and which will help us see what information we can use to query certain table. So let's say we want to know what information we can query, like based on what information we can create our query. Let's say we want to check that users, right? So we'll check the schema for users. And because I use the meta command, I'm not using a colon at the end, but it's lagging the system. And the system was lagging, so I had to restart the command line. So like I said, we'll use that schema and we'll put the table that we want to check what information is available for this particular table. So in our case, I'm checking what information I can use to structure my query based on the users table. So based on this, I have a UID. I can filter by UID, by GID, by UID signed, and username. So this is gonna be very helpful because I can know, like, based on what information I can structure my query. So let's see. Like I said, in order to know like what tables are available for us for this particular device, we'll need to know like what's our version, like Osquery version. So we can use like .show, and it will give us an output about this particular system. So our Osquery version is 4602. So it asks what is the Osquery version. It's gonna be 4.6.0.2. So yeah, it's correct. And what is our SQLite version? And here is the SQLite version, 3.34.0. Okay, now it asks us what is the default output mode. So to know the output, we'll use the help command. And here we got all the metadata that we can use. So it asks us for the default output mode, and our that mode is right here. It's setting up output, and it has couple different styles. And our default one, like here it says the default, it's called the .mode pretty. So we choose the pretty, and here we got the correct answer. It asks what is the meta command to use to set the output to show one value per line. So based on this, one value per line is gonna be this mode. So it's gonna be .mode line. And what are the two meta commands to exit Osquery? So in order to exit our Osquery, we can use a .exit, or we can use .quit. So choose .exit. .quit. So we've been introduced to some basic knowledge about the Osquery, but I just wanted to point out about this .mode, like to understand like why is it important. Because for example, you have some data that you want to see it in a certain format that it's easy readable for you. So sometimes you can use columns, sometimes you can just use lines, or sometimes you just can output the result in the priority mode. So let's say I want to select all users, because the star is gonna give everything. So I want to select everything from which table, and let's say I want to select everything from users. And you can see like I have like a lot of data here, and it doesn't look pretty for me. But I can filter, like we used that schema to check what we can like what information we can use to structure our data. For example, I want just filter by the PID, the process ID. So I can give it command PID from users. Okay, yeah, it's not PID, it's UID. Like I can just recheck it again. I'll check schema for users, and based on this I know, okay, I can filter by UID, so not PID but UID. So I'm gonna use select based on UID and from table users, and now I got all the UIDs available. And for example, I want to know the names of those users as well. So I can select based on UID, and we have username here in the schema. So I can use this filter as well. I'll put username and I'll select which table I'm querying from and close the syntax, and I got the output. So I'm now in the pretty mode because it's the default mode. But let's say I want to use the mode line, right? We have pretty, but I want to use a line to see everything based on one line. So that's where it comes this very handy to change modes whenever you need it based on what you try to query. So now I'm gonna change the mode to line, and I'm gonna run the same command for users querying. And here is another way to see that the same output but in a different format. So for example, I want to change it to columns. I'm gonna use the mode.column and do my query. See, it gives me a different way to output the information. So that's where it comes handy, this dot mode. So let's go to the next step. Now we're gonna try to use and understand how the schema works itself. So for example, if we just won't use the command line, we'll just type the tables like I showed you at the beginning, and we'll get like all these tables that are going to be available for this particular system. So let's go to the website and understand how this works in the GUI interface. Like for example, we want to filter based on our OS that is running currently on this particular device, and based on our research we done before, like widget.show, we got our version is 4.6.02, and we'll look for this particular version, and here it is. This is our version we have on our machine, and here we can choose what type of machine we have, and we run it on Windows machine. And now we got the same tables here, like the same output of the tables that we have in here, it's showcasing over here. So for example, what you can do with this, like you want to know certain details about a particular table and a brief description about it. So then you can choose from here, like let's say I want to know what information is available, like what commands I can use to query users table. So here is all these commands available. I can use a UID, which we did use, and so on, like based on username, based on description, and so on. So the same output will be here if we run the schema. Like if we run the schema for users, we'll get the same output, like UID, GID, and so on. So it's the same commands here, but here it gives you a description. So if you want to know like a particular description for a particular command that you use for a certain table, you can come up to this website, filter based on your version installed on the machine, based on your type of the machine you have, OS you run, and filter by tables, check the columns for the commands available, and see what's their description about. So that's what it tells us here, that we can use either command line to check all this, or we can go to the Osquery website where we can check the description about particular commands. So next we're gonna conduct some basic questions. So what table would you query to get the version of Osquery installed on the Windows endpoint? So because we know that it's a Windows, right, we selected here like based on our I mean, you don't need necessarily to specify a version here, but it just asks for the Windows machine, like to check the information about the Osquery. So we'll try to check a particular table that can be helpful for us. So we have Osquery, and we have info. Okay, so we'll go to Osquery info table, and we'll check what commands are available. And we see here is a version, and it says Osquery toolkit version. So we know, like based on this, and the question is to check what query we can use to check the version of the Osquery installed on the Windows endpoint. So it's gonna be the same command table, Osquery _info, and let's check. Yep, and we can run the same command here and see the output. Close command. Okay, select everything from Osquery info table, and here we got a reply to this So we can check the schema for this particular table, osquery.info, and see what we can filter based on. And we have a version, so I can run select version. I'm giving it a filter based on what to select, version from which table, and it's osquery underscore info, close it, and we got the version here. So, or you can just go based on here, and it's gonna tell you the Osquery info is the table that we're gonna use to query a version for the Windows machine. Okay, next one. How many tables are there for this version of Osquery? So, like, we can use the GUI interface, like the website, and check it. So basically, for our particular version, that is 4.6.0.2, we choose the Windows, and we have 96 tables available for this particular machine. How many tables are there for this version? Okay, for this version of Osquery, it doesn't say a Windows, so we just unselect the Windows, and we get 266 tables. And now it asks how many of the tables for this version are compatible with Windows. So now we're gonna select the Windows, and it's gonna give us particular for the Windows what tables are available. So we know it's 96 tables available for Windows. And now it says how many tables are compatible with Linux, and we'll just go on switch to Linux, and we'll get 155 tables available for Linux. Okay, the next question, it asks what is the first table listed that is compatible with both Linux and Windows. So we'll come back to this website. The version is here, and we need to check Linux and Windows. And the first table for both, it's ARP cache. So now we're gonna try to create some basic queries. And here it says the most likely, like in the Osquery, the most useful and query that you will use to start the command, the query is gonna be select. Also there is available update, delete, and couple others. So based on the command select, we can use a star, which it will show anything, and then we'll choose from, and we'll indicate which table we want to use for it, for this query, and then we'll use a semicolon to end the query. And like I said, we can use the schema to identify what filters we can use for a particular table. Like for example, in this case, for the table processes, we can use the filter by PID and the name and path. So we can use the same command and check it out. So we'll select based on PID, name, and path filters from processes table, and we'll get the output. And we got a lot of them. Let's say we want to just see the five outputs. We'll use the same command, and we can use a limit to 5. I'll get just 5 outputs. Also, we can use the count function to count for certain process. Let's say we want to know how many processes are total running on this machine. So we'll select count anything, like all of them from processes, and we'll get the output of 113 processes are currently running on this Windows machine. So like in my case, I have a mode line, but in their case they use the default one, which is pretty. So if I'm gonna change the default mode to pretty and then run the same command, I'll get an output similar, but I mean they choose the path here. So and that's it was a different query, because in this command they use path as well. Okay, so that's how you can use functions and use filters to query some information from certain tables. Here's another example where we add the clause where. Like for example, in this case we can use select based on PID, name and path from the table processes, where the name is exact name, because if we use the name equal, it means exact name. And we got the same output. But for example, let's say we don't know the exact name. We can use the same command, and instead of equal, we can use name like, and let's say I'll end in that exe. Close that. Okay, it's I need to put the wildcard here, and here we go. I got the all processes that ends in that .exe because I used the wildcard, and I mean I don't see that much output. Let's see, I can filter it by limiting it to 2 outputs. I'll get just 2 output. I got SMS and CSE, and you can even use more functions here, and you can get a better output. Like you can filter by the first, or the first processes, last process, and so on. Okay, so next, you can use filtering operations with where, like equal, not equal, greater than, and so on. So you can double check this one. The more useful one are the wildcards, like I said about the like, when you don't know the exact name, so you can use the like pattern and it will be like a wildcard, and you can like narrow down later based on this. You can use a wildcard to specify multiple characters and underscores to specify 1 character. And you can read all this on your own to get familiar with all these operations. There is another one that is joining 2 processes together. So let's say we want to join a Osquery info with the processes using PID, because both of them will have a filter based on PID. Actually, I'm not sure. Let me check if the Osquery has the PID. I'll use the schema for this, and I'll use Osquery info. And yes, it does have a PID. So in this case, we can use join, and it's gonna be based on the PID. So we'll query the PID, like let's say select PID name path from join processes using PID. So you got the output here. Okay, so we got a question here. What is the query to show the username field from the users table where the username is 3 characters long and ends with N? So we need to create a query based on username from the table users. So we'll select username from table users, and we need to specify where username. In this case we don't know exact name, so we'll use username like, and it says 3 character and it ends in N, so I'll use underscore to specify 1 character only before that N, and close it and get, and we didn't get any output. Why? Because there might not be anything in the users table with the username that ends in N and it has only 3 characters. So if you want to double check, we can select username from users and see what's there. And like you can see, here is nothing ending in EN and it has only 3 characters. So this is the syntax. Select username from users where username is like, let's go ahead. Okay, it accepted. I just made a mistypo here. It has to be like an upper comma here. It's fine. Alright, next one. Here is gonna be the Kolide Fleet, which is Osquery Fleet Manager, where you can manage multiple Osquery agents on multiple endpoints. And it's a GUI interface, and you can do the same stuffs but using the GUI interface. For our machine, it's already pre-installed, and this is the old version. This is the Kolide Fleet, but it's no longer available. And but in this case, we're gonna use this. So we'll need to set it up first, and we use like an Ubuntu, which is a Linux machine installed on top of the Windows. So like this is like a Windows subsystem for Linux installed on this Windows, and we'll need to run certain commands to start this to execute the Kolide Fleet on this machine. So here's the commands. Here's the command, and when it prompts for the password, here's the password based on this one, on this room. And the next command is gonna be we need to start the MySQL service. And for the last command, we can use the file installed already on this machine. Just find it. copy the commands from this file. So once we run all these commands, now we can use a Google Chrome and navigate to 127.0.0.1, which is our loopback address, and the port 8080. Okay. Okay, it will give us a warning because it's on unsecure protocol, but we are just doing the local connection. I'll go to advanced, proceed, and now I got the login. So it's THM. Alright, so successfully logged in. I mean, it's a bit hard to work on this interface because it's small screen here. So now we need to add a host. In order to do this, we'll need to open a Windows command line and navigate to this location and then execute the following command, and we need to input a key as well. So we need first to generate this key. So to get the key, we'll click on add a host, and here is the key. We'll copy this key and close it and come back to CMD. Okay, this is my Osquery. Open, I can close for now. And I'll command the line, and our location is users administrator. Okay, we'll cd to desktop, launcher, and Windows. And I'll use launcher. Okay, so I run the command, I substitute the enter secret key with the key generated from the Osquery, Kolide Fleet, and I use insecure, and run the command. So now if you go back to Fleet Manager, the Kolide Fleet, we need to see our device here. We'll need to restart. Alright, something didn't work out. I'll just probably rerun the command and reload the page, see if anything changed. Okay, so we don't have any hosts. Alright, let me troubleshoot it. Okay, so in my case the problem probably is the port. I mistype it. Let me rerun this command and reload the page. Okay, so now we got an incoming host. So we can see one online and one new added. So basically, if it didn't work for you or it didn't connect, make sure you wrote the syntax correct, the command correct, make sure it's online. It may still be loading, so try to refresh a couple times the page, and once the host is connected, you will see the same output here. So now what we can do, we can use to create a new query, and like here it's already an example of query entered. So if we'll run it, we need to get some output right here. And you can read all the description here and what it does, and each of these sections, what they do. Like for example, in this case here, we can put the based on the filters, we can filter it. Like remember, we use the schema to check the filters, so here it's all the filters are here. So you can just enter the filter and it will give you the output. So let's do some queries here. So what is the Osquery enroll secret? So the enroll secret is the command we typed. Let me see if it's this one. Is the key we used. The key we used to enroll. So this is gonna be the key we entered the beginning. Let me see if I can find it here. Here is my key. To move it to this. Okay, don't need the equal sign here. Copy. Here's the key. And okay, let's go back to next question. So the next question is asked, what is the Osquery version? So we can check here by version. Four 4.2.0. Now it asks, what is the path for running the Osquery osquery.exe. So for this we'll need to use table processes and then check the path and input the filter for this path. So let's go back to our SQL query here. I'll change it to table processes. Got it here and run it. And then we need to find filter path. Okay, here is the path, and here we'll use the osquery.exe. So if we just type osquery d.exe in the path file, we should get this output here, and this is the path they ask us for. Copy, use that clipboard here, copy and move to the track heavy. Okay, so let's move to the next task. Next task is the Osquery Extensions, and the extensions is another like extra features and functionality that have an additional tables, but they are not included in the core Osquery. So anyone can create extensions for Osquery. If you want to add like a new extensions for yourself, you can check those two websites and see the instructions and what our tables are available. And here we got one question. According to the polylog YX readme, how many features does the plugin add to the Osquery core? So we need to go to this website and find readme and see how many features. So we have here 25 features that you can add on. I mean, this one 25 doesn't work because when they create the room it was only 23 available features. So the correct answer for this room will be 23, but it has already 25 available features to plug in. So let's go to the next task, Linux and Osquery. So in this task we will come back to just to use the Ubuntu terminal and launch Osquery. So I can close all of this, don't need them anymore, and can close this one as well. Clear out this one. Let me close it actually. So we're gonna launch an Osquery in the Ubuntu. And here it says that we can use YARA on-demand scanning to answer some of the questions below. So we can use this website here to check some syntaxes that we may use. Let's come back to our room. So we need to answer the following question. What is the current value for kernel OS release? So for this we'll need to check something related to the kernel OS. We can use the tables here and see what we have available here related to kernel. So we got kernel info. Also you can do this by using the website as well. Like if you come here we have the version. Let's check what's our version here. .470, and we run Linux one, and we can check a table here related to kernel. You see we got the same kernel info, and here is commands that we can execute here. And the same you can see it through our terminal. Use Schema for kernel info, and you'll get the same tag, version, argument, path, device. So what is the current value for the kernel OS? So we can use the command select let me make it bigger a bit. Select anything from kernel OS, kernel info. the version right here. Just change the mode. I like to work in line. Okay, version 4.0 Microsoft. Copy it. Okay, here's Control C only works. And we got the version. What is the UID for the Bravo user? So we need to check for users. So we need to select the names from the tables, from the table Bravo. So we'll select username from users, and we can just look like this. It's a lot of them. Okay, so we can granulate it a bit from users, and we need the UID, right? So we'll use the username and UID. Filters from tables users, and where we'll use the clause where username equal, because it's exact name Bravo, and we'll get the output. So we got 1002. Okay, next question. One of the users performed a binary padding attack. What was the target file in this attack? So for this we need to check what is a binary attack. And from what I found, the binary padding, it's an attack that effectively changes the checksum of the file and can also be used to avoid hash-based block lists and static antivirus signatures. This is used commonly in generating by a function to create junk data and then append it to the end or applied to section of a malware. So because it used the binary, it means that we need to check in the kernel history somewhere. And also we can check the now on the website that I found on the GitHub. Here is a description about the binary padding and the commands it uses, and we can see it's for Linux and OS. So we know we need to look for Linux one. So based on the information we found, we can go to Osquery and try to filter and find anything related to this. So we already have a Linux, and we'll look for something that it's gonna show the history for the binary for shell. And we have the shell history table here, where we can filter based on UID, time, command, and history file. So based on this, now we can come back to our question. We need to find the target file that has been attacked. So for this we need to query the table for shell history. So we'll select any file from shell history, and we got a big output here. We need to look for certain commands that modified anything. Okay, and here is actually a command that we found on the GitHub, like how they changed it, how the attack is happening, how they run the shell. Here we go. This is the command, and we found it here, and this was the user UID 100. And what file has been changed? It was modified, because we have a modification sign here. It was attached to the Naxos. So the file that has been modified is Naxos. Okay, now we need to know the hash value for this file. So in order to get its MD5 or whatever the hash value we need to go to the file location, and from here we know the history file. It's on home directory in try-hack-me. So we can use a new window here and see our file. Okay, so we are here and just need to ls, and we have that Naxos here, and we can get the MD5 sound for it, because there was, I think, MD5, right? Modification. Let's check. If not, we'll check the other hashing algorithms. Okay, MD5 sum for Naxos, and here it is. Let's try this one. Okay, clear it out. Okay, so MD5 worked. If not, you can try different algorithm. There is SHA-256. You can get that this one and like try our algorithms, but it should be the MD5 here. Next question: check all file hashes in the home directory for each user. One file will not show any hashes. Which file is that? So we need to hash all of these files and see which one does not have any hashes. So for this question, we'll need to select any hashes, any files that have hashes that are stored in the hash table, and we'll see which one does not have any hashes on it. So let's check. Select any files from hash table where path, we will give it a path, and we don't know like exactly, but it says the home directory, so we'll choose the home directory, and we'll use double $sign to do it for all files that are in this directory. And we already get an output that it couldn't read these hashes, so it means this file doesn't have hashes. But let's see all results first. I'll just pause, wait for it. Okay, so you can just press enter and it will give you all this output, but I'll just change it the mode, because this is the pretty mode and it's too clustery for me. I'll just use the line mode and execute the same command, and I'll see what output I can get here. Okay, so now I got the output for all files that are in home directory, and I'm looking at the one that doesn't have any hashes. And you can see here I got the directory home try-hack-me fleet, and the file name is fleet.zip and doesn't have any hashes. So it's fleet.zip, and it's the right question. Alright, next question, it asks us that there is a file that is categorized as malicious in one of the home directory. So we need to query the YARA table to find this file and use the seek file which is saved in this directory. So we can choose. We can check that link that it's shared here for the YARA scanning, and we'll look for a command that we can use with SIG file. So let's find SIG file. Okay, so here is a SIG file. So we can use the SIG file, SIG group. Okay, so we can use this filter based on SIG file from YARA table, and will indicate the location. Alright, so let's go to our question. So we'll select anything, any files from YARA where path like will be, it says home directory, so anything, we don't know exact path. So in the home directory, so we use a home, and we can use anything here, and SIG file equals exact path. So our exact path is var / Osquery Yara scanner, and I'll wait for an output. Okay, so it scanned all of these, and we have here some strings. So it asks us to find the file that is categorized as malicious. So let me change the mode to the columns, or pretty, to get more structured output. Okay, so matches, we got matches here. So the file nodes, it matched. What's the file? Let's see, nodes. Yep, so that's the answer, because it matched this file, it matched the output. And this is the string, and here it matched notsus, and notsus we already know that it was changed. What were the matches? So the matches for this are those two. Can I copy it here? Yep, I put. Okay, and also what is asked, scan the file from question 3. So question 3 was that file notsus with the same YARA file. What is the entry for the string? I mean, we already have it here, so that's the string file here. So we finished with the task 9. Now let's move to the task. We finished task 8. Now we can move to the task 9. So it says for this exercise, use the either Kolide Fleet or the Windows CMD or PowerShell. So I'm gonna use the PowerShell, it's more convenient for me. Now let me deploy it. It's very slow, this emulator. for these questions, which involve the polylog YXOSQ extension bin extension, you will need to interact with Osquery via the command line. So we need to load one of these extensions that is not in the Osquery already before we can continue. So we can use the extension for this lab. So I'm gonna run this command first. Okay, so mine has been downloaded. It may take a while. I just had to restart everything from the beginning because my emulator crashed. But it's gonna take you a while to get this output done, and now you can check the tables. So you can see we got all these tables here. Alright, so let's move to the next task. You can use these sources as well to check all these extra tables that we have been downloaded, like win event, log channels, and so on. So that's the additional one that we just had to add, make this addition. So what is the description for the Windows Defender service? So we need to look for services. Alright, so I'll select anything from services, and I'll just limit to 1 to see what filters I can use. Okay. Okay, I have to restart everything. Restart everything. Okay, so select anything from table services, and I'll limit to 1. To see what filters I can use. Oh my goodness. Change this default mode. Okay, so we can filter based on name. I mean, you can do this the same using the schema if you remember from the previous tasks. You can use schema for services and get the same output, but here it's more like nicer outlooked. So based on this we can select like we have a description, right? What is the description for Windows Defender? So we need to check for description. Select from description, select description, the command is from table services, and we need to specify something related to Defender, Windows Defender service. So it should contain probably like a dev in it, so we'll try to give it a path, like where path maybe like, let's say, begins, ends with dev, and we'll see if we get the details. So we got some output here, Windows Defender, and description for Windows Defender. Like, description helps protect users from malware and other potentially unwanted software. Let's see, probably is this one. Description. And yes, that's the description they wanted. There is another security agent on the Windows endpoint. What is the name of this agent? So we need to check like all what other agents there may exist. So those agents, security agent, there should be a programs. So let's see if we have a table program. That tables. Programs. Let's see here. So we use a Windows version. Okay, check the version. That's show. Version is 4602. And I need to check for something with programs. Do they have program table here? Yes, they have programs, so we can use the query for programs. So let's say select anything from programs, and we've got a bunch of programs. And let's sort by name. It's too much info here. Let's use, instead of anything, a name. So we need a name. Okay, so here we got some names, and we have Alien Vault Agent, Microsoft. I mean, this is not security. I mean, if you research those, I'll find out that this is the one used for defending the system. And that's the answer here. Alien Vault Agent. Okay, what is required with the event log data? So we need to query the Windows event log channels first, and we'll see what's there. Select anything from Windows Win event log channels, and let's see what we got here. Okay, from, I forget to put the from. Alright, so got bunch, but we can see it requires wallet, requires a source. So this is the answer for the question. It always requires a source. So how many sources are returned for Win event log channels? We need to select count, anything, all from Win event log channels, and we got 1076 sources. Okay, what is the schema for the Windows event log? So like schema we know already, we use that schema. Schema for Win event log. Schema. Okay, I used colon because it's a metadata command here. We don't use colon. And now let's see. Okay, got a couple errors, but because I'm here it says log data and I was creating channels. So Win event log data. So this is the schema for it. All the commands, all the commands available for like filters you can use for this table. Okay, all good. Okay, the previous file scanned on the Linux endpoint with YARA is on the Windows endpoint. What date, time was this file first detected? So I need to find out the date and time when it was first time detected. So for this answer, we need to check this hint. Okay, it gives us a website where we can check more info on it. Now let's go to this website. It's a Microsoft, and it says to review event logs and error codes to troubleshoot issue with Microsoft Defender Antivirus. So based on the question, we need to find to find a command or the event IDs that will be able to look for malwares and detect the malwares. So if we come back to this website and look at what event IDs it has has scan started, completed, cancelled, post, malware detected. So let's use and find all events that we can use for detection. Okay, so I got this event 1006 and we got an event 1116. So based on this, we can come and structure our query using those event IDs. So like first of all, we need to find what's gonna be the exact name for that Windows Defender Antivirus, and also we're gonna use the YARA table because the YARA is the table used for malware detection. So like first command, we'll need to check the name, the full name for the Windows Defender. So select anything from Win mark channels in this table or source, and we don't know the source exact, but section like source like something that is with def, begins and ends with a def. So we'll look for the Windows Defender name the way they have it here. So let's see, we got the source name, we can filter Windows Defender operational. So probably this is the one. We're gonna copy this and we'll create another query based on this one and see what what we can use to filter based on. So let's select anything from Win event log data where source, because remember the source is always required, and in this case we don't need like a wildcard because we know the name. To just remove the spacing here. And I'll just limit to 1 to see the like for one of this all the filters I can use. Okay, so we got a couple of filters here: time based on date, time, source, and we need to find out the date time, right? Date time was the first detected. So now we need to use the event ID because we need to query based on those two events ID we found on the Microsoft 1116 and 1006. And we need to specify to query the YARA table for that. So we're gonna use the following command. We'll select based on event ID, we have it here. Yes, event ID. And we need date time. They will query from win event log data where our source is Microsoft. Okay, based on source, close this one, and we need to use the event ID equal 1006 and or either of those, or event ID equal 116. Close it and let's see. In our syntax where it was. Okay, I didn't close the brackets here. No such color. Event ID. Okay, I misspelled it. I misspelled it. Event ID at the beginning. Okay. Let's see now. I didn't get any output. Okay, mistype here. Let's see now. Again, same issue. Somewhere I made a mistake. Let me find out where is it. Okay, the event ID is not correct here. It's 16. Okay, so now I got it. So it asks us to see which one is the first one. So based on the time and date, we can see that this one is 44 and this is 51. So this one is the correct one, the first one. And it asks us to point out seconds. Copy. So let's go to the next one. What is the query to find the first sysmon event? Select only the event ID, order by date and time, and limit the output to only one entry. So we need to select by event ID and from win event log data. Our source is this Windows Microsoft, right? Or our source is sysmon here. So for source we'll give it the exact path, and in our case it's gonna be Windows Microsoft Windows. And it's sysmon this time. Operational. And we need to order by date time, right? It says by date time. Order by date time. And we need to limit to 1. Limit 1. And we wait for the output to come. Okay, let me see, select event ID. Okay, date and time. Let me see what's the problem here. Okay, let me try to remove the event ID here, because it doesn't ask for event ID. Just put any. Let's see if it will work this time. Nope. Maybe they want me to type it the right format. Microsoft Windows sysmon. Okay, so the issue was that I typed it with lowercase letters, and the source it has to be exact. So I had to use the exact name, and here we got all this output, but now we need to select by event ID, right? It says event ID, and just change here the filter and see now if it will work. It should work. Yep, we got an event ID, so this is gonna be the correct format. Let me copy paste and double check. So we got the correct format. Now it asks what is the sysmon event ID, and we can see here it's 16. And this one, and it's because we filter by 1, and this is the first one most likely, but we can granulate our command here by filtering order by date time and put, for example, ascending. Let's see what we'll get now. should be the same. First one, let's limit it to 5 and see what we get now. Okay, so we got first event ID, second, third, fourth, and so on. It's the same command, the same ID, so probably the same command was executed multiple times. Now we can change from descending and see the output vice versa. Alright, so that was the Osquery room in TryHackMe, and here you can explore more links and details about this. You can download it and install and try on your machine. And thank you for watching.